look at equations that are more like the ones we'll run into in circular motion. That is where a number is equal to a fraction. So when I look at this, everything in the fraction at the top can be thought of as being in the parentheses, everything in the bottom can be thought of as being in the parentheses, and the 4 can be thought of as just being 4 over 1. And can you see a variable or number by itself, you can just put that over top of the number 1. So when I look at this, this is what it looks like to me, with parentheses of everything on the top, parentheses of everything in the bottom, and then the 4 over the 1, again with the parentheses. What I'm going to do is this process called means times extremes, or cross multiplication. So you can see if I follow through the arrow, that becomes 1 times 3 times pi times 2 squared. The extremes is going to be 4 times 2, or 4 times t, and then I'll set them equal to each other. And so that's how I create a nice simple equation to work with, something more familiar. Then I apply PEMDAS to it. So I'm looking at this, and I know that 1 times any number is the number, so I'll just do that first. And then I'll look at PEMDAS, and I can see I've got the exponent, 2 squared. So 3 times pi times 2 squared. So I'm going to deal with that exponent first inside that expression. Reduce that down, it becomes 3 pi times 4 equals 4t. Now looking at the 3 pi times 4, I'm going to focus first multiplication in the order it's given. So 3 pi first. That gives me this number, the 9.42 times 4 is equal to 4t. Now at this point actually I could cancel out the 4's, but if I follow PEMDAS strictly, the next thing I'm going to do is multiply both sides by 4 to give me 37.7 is equal to 4t. And then divide by both sides by 4, and that gets me back to where I thought I was before. So t is equal to 4.42. Let's look at another example. 9 is equal to v squared over 4. So again, to solve this, everything on the top is like its own parentheses, everything on the bottom, and then on the other side, 9 over 1. Means times extremes, so I'll cross multiply. That becomes v squared times 1, which is just v squared, and 9 times 4 is 36. And then I'll set these two equal to each other. The means equals the extremes, so v squared is equal to 36. Now in order to solve this, I've got to remember something about math. That is, the square root of v squared is equal to v. The square root of any number squared is just equal to that number. So if I square root the v squared and the 36, remember, whatever you do math operation on one side, I do the same on the other. So when I do this, it becomes the square root of v squared is equal to the square root of 36, and that gives me the answer of v is equal to 6. Let's look at one more problem. I've got 16 is equal to 8.99 times 10 to the 9, 2 times 4 divided by r squared. Same process as before. Everything, think of it as a parentheses. 16's over 1, cross multiply, means times extremes. So you can see how it sets up, 16 times r squared. Set the two equal to each other, and then use PEMDAS. So the first thing I'll do is 1 times any number is itself, so I'll get rid of the 1 since everything's multiplied together. And then I'll apply PEMDAS, doing 2 times the 8.99 times 10 to the 9, and then 4 times 1.798 times 10 to the 10. That's equal to 16r squared. Divide both sides by 16, that gives me r squared. So r is equal to 6.70 for r. Alright, so while we're here with this, let's talk about one more thing about using your calculator. On a graphing calculator, I've got 8.99 times 10 to the 9 appeared in my number. It would be real tempting to type it like this in the calculator screen, 8.99 times 10 caret 9. But if you had an expression like this, 8.99 times 10 to the 9 divided by 2 times 10 to the negative 3, and you follow this idea of typing in the string with the carets, that is 8.99 times 10 caret 9 divided by 2 times 10 to the caret negative 3, it won't work. It won't give you the answer you're looking for. Because what that does, it takes the 8.99 times 10 to the 9, then divides by 2, then multiplies by 10 to the negative 3. So it's not dividing by the quantity, you need parentheses down there. It's dividing by 2, then times 10 to the negative 3. So you want to use that key that's marked EE. That stands for enter exponent, which basically attaches the times 10 to. And it looks like this, 8.99, then second, the EE key, and then my number 9. The screen looks like this. So the final answer is 4.495, exponent to the 12. That means times 10 to the 12. When writing it by hand, do not write the E, write it as 4.95 times 10 to the 12. That E notation is just your calculator texting you the answer. It's not actually the answer, so you got to put it in a formal method of 4.495 times 10 to the 12.